Hello, and welcome to Module 5 of the Partner Practice Enablement Bootcamp for Windows Azure. This 8-module training series is designed to help Microsoft's partners build their skills around selling and deploying Windows Azure. In this module, we will look at cloud services, websites, and infrastructure services. This session will focus on integration strategies for applications deployed using Windows Azure websites and Windows Azure Cloud Services. Our instructor today will be Michael Washam. Michael is the current CEO and co-founder of Opsgility, an organization focused on Windows Azure training. Michael is also a Microsoft veteran with a wide range of experience across Windows Azure that we are pleased to bring to you through this training. So with that, please welcome our instructor. Michael?
Thank you for the introduction. Hello, I'm Michael Washam, and in this session we will discuss integration techniques with Windows Azure websites and cloud services with infrastructure services as a backend. On the agenda for today's session, we will review Windows Azure compute options, specifically discussing Windows Azure Cloud Services and Windows Azure websites. From there, I will talk specifically about how to use cloud services or websites with the Windows Azure Virtual Machine as a backend. I'll discuss specific integration techniques along with the trade-offs each of these techniques bring. Windows Azure Compute. In a previous session, we spent quite a bit of time discussing virtual machines. This session, we will spend much more time further to the right of the stack discussing cloud services and websites. The idea behind the other compute models is to spend much more time focusing on writing the application and much less time on the infrastructure. Cloud Services is the original platform as a service model for Windows Azure. This solution is designed to contain all the components of an application, including files and other resources and any other dependencies it may have. The platform takes care of the operating system, so you're not responsible for managing patches, disk management, and a host of other management tasks. There is built-in application monitoring, which will automatically restart your application if there's a failure detected during a health check. Cloud services also do away with the problem of configuration drift between servers. All instances of a cloud service application are identical because they are provisioned from the exact same application package. Since cloud services are inherently easy to scale due to the stateless nature of their design, they are well suited for pay-as-you-go computing and can pretty much handle the largest workloads you can throw at them. Windows Azure Websites, as you can probably guess, is a web application hosting platform. Whether you are a digital agency creating micro or campaign sites, or you're an enterprise creating new business applications or your global web presence, Windows Azure Websites offers you flexible deployments such as TFS, GitHub, Web Deploy, Dropbox, Bitbucket, and even FTP. Websites are extremely simple to scale up and down, and websites come in 3 separate pricing models that I'll go in much more detail later in the session. The final compute option I'm just going to mention just on this one slide. Mobile services. Mobile services allows a developer to quickly build a backend for a mobile application using Windows 8, Windows Phone for iOS, Android, or even mobile applications that just use HTML and JavaScript. It's very simple to write powerful server-side scripts, authenticate users from multiple identity providers such as Facebook and Google, and easily build data services right into your application. This session is about integrating compute options with virtual machines as a backend, so due to the workloads, it really makes more sense to focus solely on cloud services and websites for the workloads. So why integrate? Building new applications using these platform as a service style compute models clearly has its advantages. There's less management and monitoring overhead, and it's easier to scale up and down when the need arises. However, many new applications are not created in isolation, and many will have dependencies on applications or data that is just not going to be easily accessible only from the sandbox of these compute models. So providing a solid and secure method of connecting to services such as SQL Server, MongoDB, Oracle, and pretty much anything else that needs a virtual machine to run in is a great solution to having the best of both worlds. The ability to jump on these new computing platforms for new applications, but also have the capability and functionality of services that run on their own infrastructure is a great mix of the platform. The other key scenario is a hybrid connectivity model. Going forward, many new applications will be built in the cloud, but that doesn't mean all the existing resources that these applications depend on are going to go with them. Many data repositories and application resources will stay on premises. Virtual machines and virtual networks provide the migration on-ramp to allow these new applications to be built in the cloud without the barriers of data locality. So let's talk about cloud services. What type of application models work really well with cloud services? New workloads, specifically, that are designed from the start to be stateless. Cloud services do not have persistent storage on the virtual machine instances, and load balancer does not support sticky session affinity. So for ease of management and ease of scale, designing applications to be stateless from the start is critical. Cloud services do have a rich model for describing, deploying, communicating across, and scaling the different tiers independently. This makes cloud services a great solution for developing new interior application architectures. Cloud services also support the concept of a startup task. This is simply a script that you can design and have it be executed on each instance whenever the cloud service is deployed. Through this model, as long as your language, framework, runtime, whatever you're using, is scriptable and runs on Windows, you can run it in a cloud service, so it's very flexible. Let's review the cloud service architecture. In the first session, we learned that a cloud service acts as a container that contains multiple virtual machines. With traditional cloud services, the model is slightly different. A cloud service contains multiple roles. A role is simply a definition or part of the application. It could be a web role, which hosts a website. It could be a worker role, which pulls orders from a queue and processes them. It really could just be whatever the developer decides it should be. There may be multiple roles inside of a cloud service, and each role can be scaled independently by specifying the number of virtual machine instances to spin up to service that role. This scaling can be changed at runtime manually or automatically using the auto-scale feature, which we'll cover in much more depth and detail in the managing and monitoring session. Another compelling feature about the cloud services model is the ability to have multiple deployment environments for staging and production deployments. Cloud services supports a deployment feature called a VIP swap. What this means is that when you're ready to deploy a new version of your application, you deploy it to the staging environment first. Once you have validated the deployment works as expected, you then perform the VIP swap, which takes a production or virtual IP, the VIP, and changes it to the new application deployed in staging, and the former production application is now in the staging slot. This swap can be performed manually or automated using PowerShell commandlets or REST API as part of your build process. Comparing the stateless web and worker roles to the virtual machine models, at the API level, a virtual machine is really just a single instance role. For traditional cloud services, you can specify any number of instances for the role. With a traditional virtual machine, you get a single unique instance, which is the virtual machine itself. These type of compute models cannot be deployed in the same cloud service. For instance, I cannot have a web role and a SQL virtual machine in the same cloud service. Knowing that these two models cannot exist in the same cloud service and they cannot directly communicate with each other by default, what is the correct connectivity story? Well, there are two to choose from. The first option is to connect directly between public endpoints. Just like we learned in the networking session, it is relatively easy to open up a public endpoint on a virtual machine and allow a connection in. Using an access control list, it's easy to restrict traffic to only a specific source, such as the cloud service. This option does require a single port to be open at a time, as endpoints on virtual machines don't support ranges. The second option is using a virtual network. Just like virtual machines, cloud services can be directly deployed to the same virtual network that your virtual machines run on. This gives you the ability to directly access all the resources on the virtual machine from your cloud service applications. Let's review this model in more detail. For example, let's use a web role hosting a website in Cloud Service 1 and a SQL Server backend being hosted in Cloud Service 2. This, of course, doesn't have to be a SQL virtual machine in the cloud. It could be any service. It could even be a REST API that queries a database on premises using a VPN tunnel for hybrid connectivity. Some of the strengths of this model: the model is relatively simple because there is no complexity of virtual networking to worry about. Tenant autonomy: the cloud service application is completely separate from the cloud service hosting the virtual machine. They realistically don't even have to be in the same subscription or even the same data center. They should, but they don't have to be. It is simple to do development and test because the services exposed by the virtual machine could also be consumed on the developer and tester's workstation completely outside of Windows Azure at all. Some of the weaknesses: since the application is accessing the cloud service from behind a load balancer and the other services also behind the load balancer, there are going to be a couple of extra hops to make the request. This isn't a great deal of latency as long as they are in the same data center, but it is measurable about 0.39 milliseconds. Since the service is listening on a public endpoint, you're also responsible for securing that endpoint and any other endpoints that are open that the service needs to make available to applications. In this demonstration, I'm going to walk through creating a cloud service with the SQL Server virtual machine as a backend. For this example, we're going to demonstrate connecting over the public internet using the virtual IP address of the SQL Server as a connectivity endpoint for the cloud service. So the first thing I need to do is to actually create the SQL virtual machine. So I'm going to go ahead and choose Compute from the gallery experience. And for SQL Server, I'm going to choose SQL Server 2012 SP1 Enterprise on Windows Server 2012. So I'll call this machine SQL VM, keep it nice and simple, and demo user as the username, and the super secret password. Next, I'm going to go ahead and create a cloud service for this. This will be SQL Service Demo 1, and I'm going to put this in West US. And finally, I'm going to add an additional endpoint through the creation for MS SQL, and this will open up port 1433, which is what SQL listens on. And this is the endpoint that we'll use to connect to the SQL Server from Windows Azure Cloud Service. Go ahead and click OK. Once the virtual machine is provisioned, I'm going to walk through configuring a data disk and configuring two data disks, one for the data disk or the data for SQL Server and one for the transaction logs, because best practices for SQL Server, usually these should be on separate disks, and virtual machines give better IOPS if you distribute traffic, actual I/O to multiple disks on the virtual machine. So until the virtual machine is provisioned, I'll go ahead and pause and we'll come back shortly to finish configuration. Now that the virtual machine is completed, let's go ahead and attach two data disks. So I'm going to click attach empty disk, and I'm going to call this SQL data, and make this a 250 gig disk. Leave host cache preference to none because this is a data disk. We certainly don't want host caching enabled. And as soon as this disk is attached, we'll go ahead and attach another one. That way we have a disk for our transaction logs. So the first disk is attached, so let's attach one more. Call this SQL logs, and make this 100. While the disk is attaching, I'm going to go ahead and log into the SQL Server. And once we're logged in, we can start configuring SQL Server and upload the database that we're going to use for our cloud service application. So now that the server is booted up, I'm going to go ahead and start SQL. And while SQL Server Management Studio is starting, I will launch administrative tools because we're going to format the two disks that we just attached and prepare them for uploading our data. So I'm going to pull up disk management and initialize the two empty disks. Create a new simple volume. This one will be the F drive, and I'll call it data. While that one's formatting, I'll format the second disk. Go ahead and create a new simple volume for the transaction logs. Put it on the G drive, and we'll just name this volume logs. So while the two disks are formatting, or the second disk is formatting, I'm going to go ahead and upload to the D drive, the temporary drive, the AdventureWorks database that we're going to use for the SQL Server for the sample application. So I'll go ahead and just paste this in over RDP. It's only about 40 megs, so shouldn't take too long. And while that disk is copying, I'm going to go ahead and pull up SQL Server Manager and connect to the SQL Server and configure some of the default SQL settings that we're going to need to change. So the first thing I want to do is pull up the properties for the SQL VM, and I'm going to change the default location. So for the default data location, I'm going to change this to the F drive. For default logs, change this to the G drive, and same thing for the backup directory. So now any new databases that we create will automatically have these default settings. Next thing I'm going to do is switch over to security, and I'm going to change this from Windows Authentication Mode to SQL Server and Windows Authentication Mode because we're going to be connecting over the public internet and we won't be able to pass Windows Authentication. Press OK, and now I need to restart SQL. So the next thing I'm going to do is create a SQL Server login for our web application to use from the cloud service. This is going to be a SQL Server authentication login. So I'll just call it demo user and make the default database to be, actually, that's default database is fine. Go ahead and press OK, and now I need to actually create the AdventureWorks database before I can configure the rest of the security. So I'll go ahead and extract the two database files that come with the AdventureWorks sample. I'm going to put the data file on the data drive and the log file on the log drive. And finally, I'm going to attach the database. So click attach, and I'm going to attach the data file. And for the log file, I need to change the directory to the G drive and select that right file. Okay, so now I need to add that login to our AdventureWorks database. So I'm going to go under AdventureWorks, under Security, Users. So let's go ahead and add that user. Right click, hit New User. I'm going to browse to the user. Give them the username, demo user. And for membership, I'm going to go over and I'm going to select DB owner. That way this user has full access to the AdventureWorks database. The next step I need to do on this virtual machine is back under administrative tools, and I need to open up the firewall for port 1433 for SQL. We opened it on the endpoint for Windows Azure, but we haven't opened it up on the local Windows firewall yet. So I'm going to go ahead and choose port 1433 and just name this rule SQL. So now the SQL virtual machine should be completely ready to have connectivity from a remote client. So the next thing I want to do is I have a sample application. This is one directly from the Windows Azure Training Kit called the Cloud Shop. So I'm going to open this up in Visual Studio, and if you're an IT professional and you're not used to using Visual Studio, this should be good for you to know how a cloud service application gets constructed and packaged and handed off to you, because in all likelihood, this is what your developers are going to do. They're going to customize the application, package it up, hand it to you to deploy, manage, and monitor. So I'm going to open up the web config for the web application, and now we need to go and change all the connection string to use the information we just created. So first thing I need to know is the virtual machine's cloud service name. So I need the full demo URL, and this is SQL Service Demo 1. So I'm going to go change cloud service to SQL Service Demo 1. I'm going to change the user to be demo user, and the password is the super secret password that you shouldn't tell everyone about. So I'm going to do the same thing for the second connection string. Make sure that's right. SQL Demo Service 1, SQL Service Demo 1. See, almost. And user is demo user, and the password is, again, this super secret password. So now, the Windows Azure SDK has a built-in emulator in Visual Studio that you can run locally to make sure that the cloud service works. So I'm going to go ahead and run that first, just to make sure so I don't spend time deploying my application and for it actually to have been misconfigured. So we'll go ahead and give it a moment, and there it is. So the application does work. So the next thing I'm going to do is package up this cloud service and get it ready to deploy to Windows Azure for real. I can actually deploy it directly from Visual Studio. However, in a real-world environment, this is not probably going to be the most applicable solution. What I expect is going to happen is the developers are going to go into and use the package option, which allows you to choose the configuration you want to choose and click package, and this will actually take the entire application, put it in essentially a zip file, which the extension is actually a CS package, but it's actually under the hood it's a zip file, and a service configuration file. And these two entities are what you use to deploy a cloud service into Windows Azure. So I'll go ahead and take this URL, go to New Compute, Cloud Service, Custom Create, and I'll call this Cloud Shop Service 1. And I'm going to put this in the same data center that my SQL VM is deployed in. Deploy Cloud Service, call this My Cloud Shop, and I'm going to browse to the package file, which is right here. And I'm going to browse to the configuration file, which is right here. And I'll go ahead and click the Confirm button to go ahead and create that deployment. Now for the moment, I'm going to go ahead and pause the recording until the deployment actually completes, because it does sometimes take a few minutes for it to completely deploy. So the cloud service has completed deployment. So let's go ahead and validate that it did work. So I'm going to copy the shortcut to the cloud service URL, launch a new browser, and refresh, and it does work. So we're able to connect to the SQL Server over the public Windows Azure endpoint. Next step I want to show you is how to secure this endpoint. Right now, 1433 is open. Anyone that knows that SQL username and password can connect to it remotely from any location, period. So what we want to do is restrict it so that only the cloud service can access the SQL Server and not anyone else. So to do that, I'm going to go and get the public IP, the virtual IP address of the cloud service itself, which is 168.62.5.159. And I'm going to go back to the virtual machine for the SQL Server and click on Endpoints, and we're going to modify the ACL for this MS SQL endpoint. So I'm going to paste in that IP address and make it a /32, which means only this one specific IP address. And then I'm going to deny everyone else, which is 0.0.0/0. So go ahead and click OK here. And now our access control list will be restricted for the MS SQL endpoint, so only that one specific cloud service can access this virtual machine remotely. This is essentially how you can connect a cloud service to a virtual machine without using a virtual network, which we'll talk about shortly, and have it completely secure going over the public internet. So the final piece I do want to show in this demonstration is how to scale a cloud service. So I can open up my cloud service and click on the Scale tab, and down at the bottom you can see the instance count. The instance count is set to 1. I didn't change it in the configuration. You can set that before you actually do the deployment in Visual Studio, or you can go into the portal and change it all the way up to the maximum quota for your subscription. My quota only allows me to do 20 instances right now, but you can call support and have that escalated up to, in the thousands if you have a gigantic service you need to run. change this to a more reasonable number for my little sample, and click Save. And Windows Azure will automatically take that same application and deploy it on 3 other instances configured with load balancer. And that is essentially how you scale out with cloud services. As you can see, we're going to talk more about this in the management and monitoring session too, but there's also auto scale settings. So I can have a cloud service auto scale on a specific time or day. I can have it scaled by specific metrics such as CPU usage, or if you're reading from Windows Azure storage queue and the queue gets high, you can set queue quotas where if it reaches a certain amount, add more instances to process a queue. And again, we'll talk more about the auto scale capabilities in a future session. The other option for connecting cloud services to a virtual machine backend is by using a virtual network. The strengths in this approach are numerous. There's less hops since you're not going through the load balancer, and this equates to lower latency. There are no public endpoints to secure, so from a security perspective, this is a simpler approach. Since a cloud service and the virtual machines are on the same network, this allows applications that have advanced connectivity requirements with lots of port ranges, such as DCOM and Active Directory, to work. Some of the weaknesses: virtual networks are slightly more complex to configure. Without deploying your own DNS server, the connection strings for your application will have to be based on the IP address of the virtual machine, because the Windows Azure DNS service does not span cloud services. The final point here is if you'd like to do local development and test against a virtual machine in a virtual network from a machine outside of the virtual network, you'd either have to open up a public endpoint, just as a previous scenario, or deploy point-to-site connectivity where you have a configuration from the client machine to the virtual machine, or site-to-site if you had a number of developers and testers that needed direct connectivity to the virtual machine. In this example, we're going to walk through and create the exact same scenario, except this time, instead of having our cloud service connect to the SQL Server over the internet using a public endpoint with an access control list, we're going to deploy both the cloud service and a virtual machine onto a virtual network and establish connectivity directly using the IP address of the SQL Server. In order to do that, I need to create a virtual network. So I'll call this SQL VNet, and I'm going to put the virtual network in West US, so I'll call this SQL VNet AG. From here, I don't need to specify a DNS server or point-to-site connectivity or site-to-site connectivity, because the only connectivity that's going to be here is a cloud service to a SQL VM, and we're not using AD to make that happen. On the next page, I'm going to create 2 subnets, one for SQL, and I'll just make this a /24. Doesn't have to be that big, but why not? Got all the address space I need. And we'll make another subnet called Cloud Service. That's also /24 for simplicity. Go ahead and click Complete to create the new virtual network. Now my next step is I'm going to go ahead and deploy the exact same SQL Server configuration as before. So I'll go to Compute, Virtual Machine from Gallery, and choose SQL Server and Windows Server 2012. I'm walking through creating the virtual machine, as it is a little bit different because we're deploying onto a VNet than before. So this time we're going to create SQL Demo Service 1, which is fine, and I'm going to put it into the SQL VNet this time around instead of creating on the location. And that is pretty much the biggest difference between how I created the virtual machine before and now. I'm also not going to add the SQL 1433 endpoint. So for now, I'm going to go ahead and pause the recording so we don't have to walk through and configure data disks again, because we just saw that in the previous demo. All of the previous configuration that you saw is going to be the exact same for this demo until we get past the SQL Server and start provisioning cloud service. Okay, so the SQL Server, after a long pause, has been recustomized. I've added data disks. I've had it completely configured exactly how it was before, except it is now deployed on the virtual network. So the next step I want to do is deploy the cloud service on the same virtual network. So I'm going to switch back to our cloud service project, and I need to modify 2 different places. The first place I need to modify is web config. So currently this is going to SQL Service demo1.cloudapp.net. Now I need to actually point it to the SQL Server's IP address. So to get the IP address, I can click on the SQL Server, or I can also see the same resources from clicking on the virtual network. So you can see that the IP address for the virtual machine is 10.0.0.4. So go in here and modify 10.0.0.4. And the same with this cloud service, 10.0.0.4. So now the IP address for the application, the web application, is correct, but I need to put the cloud service itself onto the virtual network. And to do that, there's a little bit of configuration that I need to add. So the first thing I'm going to do is open the service configuration.cloud.csfg. This is a configuration file for the cloud service. I can set the instance count, so instead of starting with 1, I can set it to 10 or whatever I want it to do. There's all kinds of other configuration options I can do here. The main thing that I'm worried about right now is configuring a network. So I'm going to add a network configuration element. I'm going to add a virtual network site. And I'm going to put this on the SQL VNet, which is what we just created a little while ago. Next thing I'm going to do is I'm going to specify an address assignments element. Put an instance address, and this is basically looking for the role, which as you can see right above is Cloud Shop. Inside the instance address, I'm going to specify the subnet. I want these cloud services to, the virtual machine instances to provision off of. So specify the subnet, and that was cloud service. And that is pretty much it. Everything I need to do from the cloud service perspective for deploying it into Windows Azure. So I'm going to go ahead and package this cloud service up, just as we did before. Let it go ahead and compile the CS package and CFG. And there is a new build. So now I'm going to go back to the portal, click on New, Compute, Cloud Service, Custom Create, and we'll call this Cloud Shop Service 1. Make sure it's all nice and unique. It is going to be deployed into the SQL VNet AG affinity group. And you don't have to specify the virtual network here because it's actually specified in the service configuration file, but it does have to be in the same affinity group that the virtual network is deployed in. Give it a deployment name and now specify the actual files. So here's the source package file, and here is the source configuration file. And click confirm, and it will start provisioning the cloud service into the virtual network. So again, this is a rather lengthy deployment. Only one instance. It doesn't take too long, but probably way too long to sit through a webcast of silence. So I'll go ahead and pause the recording. We'll be back momentarily. So now the cloud service has officially deployed. So we can go down to networks and SQL VNet. Same place we saw the SQL Server IP address. We can see that the 10.0.1.4 address is there. So our cloud service instances are getting IP address off the same virtual network. So if we switch back and go back up to cloud services, get URL for this cloud service, launch it in a browser. Let's make sure it can connect. And there we go. We are connected to the same SQL database, except this time, instead of going over the public internet and connecting over the endpoint using an access control list for security, we're actually connecting on a private network using a virtual network. And it was really straightforward to set up. Now that you've seen some of the options for connecting a cloud service to a virtual machine as a backend, let's examine Windows Azure websites for similar capabilities. Windows Azure websites are the easiest and fastest option for deploying new web applications in Windows Azure. You can start with the free option for simple development and test, and easily move up to more powerful scenarios with the shared or standard model. There are command line tools available on Windows, Mac, and Linux for management and deployment automation. Best of all, deployment is nearly instantaneous, so it's very easy to quickly iterate. Some users literally deploy hundreds of times per day. Website deployment is all about being agile and flexible. Whether you just want to simply FTP your content for deployment or deploy with more advanced continuous integration using applications like TFS, Web Deploy, Git, or even Dropbox, there are plenty of options. GitHub, Codeplex, and Bitbucket are also supported using a Git service hook. Windows Azure websites have recently introduced the concept of a staging site and swap feature. Similar to cloud services, you can now deploy to staging site, verify the new deployment is valid, and then swap to production when you're ready. With websites, you can deploy applications that are built on classic ASP, ASP.NET, PHP, Python, and Node.js. You do not have to worry about the runtime itself because it's built into the platform. Also, any framework that supports the fast CGI handler and IS is also supported. Windows Azure websites have 3 pricing models. Free, which is up to 10 sites. This is great for prototyping and dev test scenarios. Shared, this is running on a shared CPU with up to 6 shared instances and 100 sites. Standard, this is dedicated CPU with up to 10 dedicated instances and 500 sites. Free and shared plans are multi-tenant by nature. This means that virtual machines your websites run on could potentially have other websites hosted on them as well. The free tier only supports a single instance and does not support custom domains, but it can host up to 10 free websites. The shared tier can run on up to 6 instances and supports custom domains. Shared can also support up to 100 sites. The standard tier can run on up to 10 instances and supports custom domains and SSL. Standard runs on dedicated virtual machines, so there is no worry about quotas that are used to keep tenants from interfering with each other. With the shared model, your website starts off on a single instance with other tenants. With a simple configuration change, you can easily add more instances, up to 6, Shared instances are 33% cheaper than dedicated. With the standard model, your website runs on the dedicated instance. You can choose a virtual machine size, whether it's going to be small, medium, or large. And it's easy to scale out multiple dedicated instances all the way up to 10. This allows you to run multiple websites on your dedicated instance. With the standard edition, you can also enable autoscale to truly only pay for what you need. When CPU usage goes above, Windows Azure automatically will add instances. When CPU usage goes back down, Windows Azure will automatically adjust down. If you get a burst of traffic, Windows Azure can scale out even more instances. You have full control over the autoscale tactics. The minimum instances, the maximum instances, and the metric rules, which are not just CPU, can also have it adjust based on a queue on which autoscale will execute on. Now that you know the basics of what Windows Azure websites are and what you might use them for, let's examine the scenario you have where you have a backend hosted on a Windows Azure virtual machine. This is very similar to the benefits of connecting a backend virtual machine using cloud services. The most important aspect is that from your easy to manage and easy to scale website application, you can access services hosted on a virtual machine. This could be as simple as a SQL Server or a SQL Always On cluster. It could also be a REST API that accesses data from an on-premises database or on-premises service to enable hybrid applications. The virtual machine itself can be a management overhead, but depending on the application, the trade-off is to enable you to host a significant portion of your application in a managed platform like Windows Azure Websites. This alone usually far outweighs the downsides of hosting services in a virtual machine as well. Since Windows Azure Websites only supports connectivity through the VIP, the public IP, scenarios like DCOM and Active Directory will not easily be available without some server-side changes, such as configuration or creating wrapper API. This model does require shared or standard mode in order to have a persistent IP address, and without the persistent IP address, you can't use an ACL to lock down and have full security. In this example, I'm going to walk through the same scenario that I demonstrated at the beginning of the session with a cloud service connecting to a virtual machine over a public endpoint with an access control list, except this time we're going to create the scenario using a Windows Azure website. So to get started, I'm going to create a new Windows Azure website, and I'm going to use the gallery experience. And in the gallery experience, you can see that I can pick multiple applications. I can use different application frameworks, different blogs such as Drupal and Blog Engine, Ghost, etc. The example I'm going to use right now is going to be a CMS. I'm going to choose Orchard. And the main reason I'm choosing Orchard is because as part of the setup process for Orchard, it allows you to specify a connection string to a database. So I'll go ahead and click Next. And I'll give it the website URL, so let's call this Orchard Service 1A, just make sure it's unique. And I'm going to put this in West US. And I want to choose West US because I want to make sure that it's in the same region as the database, so we're not making database requests across the country, which would obviously introduce a lot of latency. So I'll go ahead and create the website. Now that the site is up and running, I'm going to go ahead and right-click and hit the URL, just to load the site up, make sure everything is working right. Okay, as part of loading the site, it wants basically the name, the admin username, etc. So we'll call this Orchard Demo Site, Demo User, our super secret password, and now it wants a connection string to a SQL database or MySQL database. So in order to do that, let's switch back over to the Windows Azure Management Portal, and I'm going to open up an endpoint on the SQL virtual machine that we used in the last demonstration for virtual networks. So Windows Azure websites cannot connect directly on a virtual network, so we do have to use the first connectivity option of using through a public endpoint. So I'll click Add, Standalone Endpoint, change the drop down to MS SQL, which is 1433, and click Confirm. Now, while this endpoint is loading up, the other thing that this Orchard setup requires is a database be created. So I'll go over to the SQL virtual machine and I'll create a new database for it. Let's call the database Orchard DB. And from there, I need to create a new user in the database. So I'm going to go ahead and reuse the same demo user that we used in the previous demo. And for membership, I'm going to make him a DB owner, so has full permission to create tables and everything on the database. Give him a name too. Okay. So the permissions are set up on the database is created, and our endpoint in the virtual machine is created as well, almost created. So the next thing we need to do while this is still updating, which it just finished, is add the database connection string to Orchard. So I'm going to say data source equals, I need the cloud service name, the full DNS name for that virtual machine. Flip to the dashboard for the virtual machine, get the DNS name, flip back to Orchard. Initial catalog is the name of the database itself. So Orchard DB, persist security info equals true, and user ID equals the same username that we did in the previous demo. And last but not least is the super secret password. So this is everything we need to complete our orchard setup. So I'll go ahead and hit finish setup and let it do its thing. It's going to log in and create tables and copy content and have everything all set up in Orchard. So the Orchard demo site is up and running. This is just a sample brand site that comes up automatically when you install the software. So the next thing I want to show you is how to configure scaling for this website. And move over to the scale tab so we can see how to actually scale this website up a little bit. So on the free SKU, you can see that I cannot change the instance count. One instance is maximum you can do, and this is on the extra small shared core SKU for the virtual machine instance it's actually running on. I can switch this to shared, which means I can scale up to 6 instances. This is still on the extra small shared core though, so other web applications could be running on your servers, but your application is going to be spread across 6 instances, so it's going to be fairly scalable. The third option is standard, which whenever I'm running on standard, this is dedicated virtual machine instances. I can pick the instance size from small, medium to large, and I can enable auto scaling. So I can set up a schedule, or I can just turn on a CPU, and basically if it's whatever the target CPU is, if the average CPU utilization for all my instances is within this range, Windows Azure will automatically add instances up to this limit, which is all the way up to 10 instances. I can set a minimum of 1 instance or however I want to do this range. So let's leave this at 2 and have it auto scale up to 4 instances if the website is getting hit hard on CPU utilization. So go ahead and click Save and let it scale. So this is really all you need to do to manage the scalability of your Windows Azure websites. Obviously, good application design, your backend are very important too, but the actual web server itself is extremely easy to manage from a scalability perspective. Now, the last thing I do want to show is how to secure that SQL Server endpoint. So in the cloud services, we saw how we can create a access control list that points to the IP address of the cloud service. So if I go here, it tells me that no IP address SSL binding is configured. And what this is saying is basically I can't have a virtual IP address that I can secure unless I have a custom domain. So if I go over to the Configure tab, and once it loads, I can go down to Manage Domains. And Manage Domains tells you the IP address to use whenever you configure A records. So I can take this IP address, assuming I put a custom domain on, it'll stay persistent. I can go back to my virtual machine, go back to my SQL Server endpoint, and click Manage ACL. And I can allow this IP address to have permissions to the SQL database. And just like before, if I want to make a very explicit deny to make sure that I know what's going on here, I can make a deny rule and make this available to everyone else. Once the endpoint is updated, the SQL Server virtual machine endpoint will only allow access from this specific IP address, which is on a dedicated endpoint, so there's not going to be any chance of any other servers having access to this endpoint. So once the endpoint is updated, we can then go back to the website, refresh it, and everything should be working. Okay, so the endpoint has been updated. Go ahead and click OK. I'll flip over to the Orchard site and hit F5 to verify that indeed we do have access. So refresh the site and everything works. So in this example, you've seen how to deploy a Windows Azure website using the gallery option, which allows you to pick a bunch of pre-configured and freely available applications such as Orchard CMS, and how to connect from the Windows Azure website back to a SQL Server and using a access control list, secure that connection. And finally, you also saw how to configure autoscale and then basically have automatic scaling of multiple instances for your Windows Azure website. In this session, you learn more details about the other compute models in Windows Azure: cloud services, websites, and mobile services. You learned how you can use cloud services to create highly scalable, stateless applications that can integrate with applications and services on virtual machines in 2 ways: by connecting through a secure endpoint, and also by connecting directly using a virtual network. You learned how Windows Azure websites can be used to easily deploy, manage, and scale web applications, and that they can integrate with applications and services on a virtual machine using secure endpoints like cloud services. You also saw how you can enable autoscale to have applications hosted in Windows Azure websites automatically scale up or down to meet, man, and save money in the process by not paying for instances you're not using. Here's a list of some related exercises you should try out on your own to learn more about the topics in this session. Here are some additional resources specific to this session. And finally, some resources that are really good for Windows Azure in general. Coming up next, we'll talk about SQL Server and SharePoint, learn best practices for management and deployment of these two critical workloads in Windows Azure. And thank you for watching this session.